Hello everyone, I am Rahman, a mechanical engineer, and today I want to do this short video on electric vehicle motors. But I want to do it in a way that anyone should be able to understand, or at least anyone should be able to follow. Alright? So let's start with the basic principle of technically all electric motors. Let's say we have a magnet, north and south, and beside this magnet there's a wire, and let's say we have a current that flows through that wire. Well, in this case, the current flowing through the wire beside the magnet will produce a force, and that force is described by the equation called the Lorentz equation. And this equation says the force will equal the length of the wire times the current and cross B, which is the direction of the magnet. So again, this happens in nature. It happens naturally. And this setup, this equation is from physics. So when we have this, we might want to make it useful, to make it practical. And we can do that by tweaking this a little bit, like so. North and south. So now instead of just having a wire that runs through, we can coil the wire around a center point. And when we do that, we have a distance and a distance. You see, now we still have the wire producing the force and acting at a distance. And this gives us a torque, and which equal the 2dF. All right. So when we have this setup, we can even tweak it further to produce a constant torque, like so. We have the magnets again, north and south. Now instead of just having one coil of wire, we can have several coils of wires. And we can have these wires at an angle. And now the torque here is just the 2dF cosine theta. So basically, these are the fundamental principles of electric motors. You see, when we have this now, we can design a simple motor. So let's design a simple motor. In designing our motor, we have to think about what goes in and what comes out. We know we're going to have power is going to go in and power is going to come out. So we start with that. And we know that the power that's going to go in is simply just going to be the electrical power. And that's just going to be the voltage and the current. But what will come out now, there will be several stuff that will come out. And one of those things, it will be power to do a mechanical work. From this equation, we know that power here is equal the torque, which is 2dF cosine theta, multiplied by omega, which is the angular velocity. And we can write it like so for space. So we know our motor would produce a power to do a mechanical work. And so we can bring that down here. Torque omega. We also know that we will have a friction that will be produced. There will be some power loss due to friction. So we also add that here. The coefficient of friction times normal force. And we also know, again, since we have coils inside our motor, and those coils are beside a magnet, that will produce an inductor or inductance energy. And I like to consider inductor as similar to kinetic energy. For example, kinetic energy is simply half mv squared, and inductance energy now is simply just half Li squared, right? From here we can get power by simply we get power we simply integrate the inductance energy, and that gives us Li di dt. So this is the power due to our inductance, and so now we bring that down here as well. That will come out of our motor. We also know that we will have some energy loss due to our resistance, because again, current will flow through the wire, and the wires produce some kind of resistance, so we'll have some power loss due to resistance, and that's simply just the I squared R. And this is just from the normal equation from power, and that again is just power V is equal to VI, which also equal I squared R, which also equal V squared R. And we just use one of the component that has resistance. So from here, I believe we might lose energy due to sound. We might have some power loss due to sound. I think the equation for sound is just P times T. There could be other stuff, but I believe these are the main considerations. So from here, we simply just set up our equation. P in should equals P out. Again, what goes in is simply the electrical power, which is the voltage times the current, and what comes out is power due to mechanical work, omega times time. Oh, another thing, we can assume that our motor is efficient to a point that the power loss due to friction can be considered negligible. So in that case, we can just say the power loss due to friction is 0, and we can do the same thing here as well for the power loss due to sound to be negligible or to be be 0. So now in this case, we only have to worry about the power due to mechanical work and the power loss due to inductance, Li di dt, and the power loss due to resistance. So this is the equation for our motor. And from here, now you just use algebra to solve for any variable. And technically that's it. So I will end the video here, and I hope that this is helpful. I might do a similar short video on the principle of batteries and range. So again, thanks for watching and thanks for listening.